Welcome back to Low Stress Math with Mrs. Bono. Still Chapter 1 Exponents, and we are on, not page 19, Bono, page 16. So, lesson number 4. We're going to be learning about the product rule of exponents, or the product law of exponents. Depends on who's telling you about it, but I like the word law. And here we go. Product rule of exponents. And we are really just going to learn the shortcut to how to multiply expressions with exponents. So really today's target is to learn the easy way to multiply expressions with exponents. I'm going to put quotes around easy, because you know what I mean, the easy way to multiply expressions with exponents. So take a minute right now and pause the video and try to do the warm-up yourself. I'll go over it, but I want you to try it yourself. So pause now. Welcome back. So this is definitely wrong. 6 to the third power is not 6 times 3 equals 18. So what did the person who did this do? They used the exponent incorrectly. So this problem is using the exponent incorrectly. And what do I mean by that? The exponent is supposed to tell you how many times to use the base as a factor. And they just multiplied, and you're not supposed to do that. So the exponent tells you how many times to use the base as a factor. So the base here is 6, and the exponent is 3. That 3 says to use the base 6 as a factor 3 times. So 6 times 6 times 6 to get a result of 216. So 6 to the third power is really 216, and that is very different than 18. Now, on the bottom, I'd like you to try the table. I'm going to go over what I mean by this. So you're going to take the product, which is 2 to the fourth power times 2 to the third power, and write it in expanded form. So what I did was I took 2 to the fourth power, and I expanded it to 2 times 2 times 2 times 2. Then I took 2 to the third power, and I expanded it to 2 times 2 times 2. And when I simplified it, I just counted the total number of 2's. 1, 2, 3, 4, 5, 6, 7. So the base is 2, and I used it as a factor 7 times. So my exponent is 7. For this problem, I did something very similar. Now, remember, when you have parentheses around a negative number, that means the whole base is negative. So my base here is -3, and I have to keep the parentheses. So -3 times -3. But I also have -3 to the 4th power. So that's -3 times -3 times -3 times -3, 3 to the 4th power. But in total, I have -3 in parentheses, because that negative is glued to it, and there's a total of 6 -3s. So -3 is being used as a factor 6 times. All right, down here, I am going to find a nice, here we go, 7 to the 3rd power, this one. That is 7 times 7 times 7. Okay, and 7 squared times 7 times 7 again. So I have a total of 7 being used as a factor 5 times. So 7 is the base, and it's being used as a factor 5 times. Now I have parentheses again. Parentheses mean that I'm keeping 1/5, the whole number, as the base. So there's 1/1/5 here, so 1/5. And this has 1/5 to the exponent 4, so I have to use 1/5 as a factor 4 times. My base is 1/5, and it's been used as a factor a total of 1, 2, 3, 4, 5 times. Down here, again, negative base, because it has the parentheses around it. So -4 squared, to expand that, I write it twice. -4 times -4. But it's being multiplied by -4 squared. So that's -4 times -4. Keep the parentheses because the base is negative. -4, and there's 1, 2, 3, 4 of them. So -4 to the 4th power. Ha. Oh dear, seems like a lot of 10s in this next one. 10 to the 3rd power. 10 times 10 times 10 times 10 to the 5th power. 10 times 10 times 10 times 10 times 10. Writer's cramp, Bono. Stop making big numbers. All right, so 10 is used as a factor 1, 2, 3, 4, 5, 6, 7, 8 times. Wow, that's a lot of 10s. Very tense here. All right, compare the product and simplified expression. So this first column is the product, and this last column is the simplified expression. 2 to the 4th times 2 to the 3rd, 2 to the 7th. -3 squared, -3 to the 4th, -3 to the 6th. What's happening there? Well, the first thing you notice is that the base stayed the same. So the base has stayed the same. But what happened? Well, look. 10 to the 3rd, 10 to the 5th. Base of 10, 3 plus 5, 8. -4 squared, -4 squared. -4 is the base, but 2 plus 2, 4. 1 plus 4, 5. 3 plus 2, 5. What's happening here is the exponents are being added. All right. So that is the law of exponents. When you, or the product rule, sorry. It's our first law of exponents, the product rule. You're going to keep the base and add the exponents. But it's really specific when you're allowed to do that. When the bases are the same and you're multiplying, keep the base and add the exponents. When the bases are the same, it doesn't always work for other things. and you're multiplying, keep the base. Keep the base. I wrote that all in capitals because you know I'm yelling at you. Keep the base. It's very important. Keep the base and add the exponents. Product rule represented algebraically. Remember this word, it's going to show up a lot. Algebraically means that you are using the rules of algebra and variables and numbers. So be careful. Algebraically means you have variables, like here I have my base A, and m and n are the exponents. So it's a to the m power and a to the n power. So I'm multiplying those two exponential expressions. So I'm going to add, keep the base A, and add m plus n. No numbers, but I'm still using the product rule. Directions, expand and simplify each expression below. So here I have -5 in parentheses, and it's 2. It doesn't have a power, but you know when there's no exponent, the exponent is 1. Now I have -5 to the 6th power, so -5 times -5 times -5 times -5 times -5. And I'm going to double check. I have 6 of them. 1, 2, 3, 4, 5. Oh, I lost one. -5 to the 6th power. So keep the base, -5 in parentheses, and the exponent is how many times I used it as a factor. 1, 2, 3, 4, 5, 6, 7. I used -5 as a factor 7 times. Here I have x. My base is x, and it's to the 3rd power, so x times x times x, and that's being multiplied by x to the 7th power, times x times x times x times x times x times x times x. Double check. 1, 2, 3, 4, 5, 6, 7. I'm getting better at this. All right, so my base is x, and I'm using it as a factor 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So the base is x, it's being used as a factor 10 times. So down here, the product rule and simplify it. Now, very often when you're doing the product rule or later on some of the other laws of exponents, they're going to ask you to show your work. And in order to do that, all you have to do is write down what you're doing. You're keeping the base, x, and you're adding the exponents, in this case, 14 plus 21. So I write that as the exponent. So I keep the base x, and 14 plus 21, 35. For the next one, I keep the base n, but now I'm adding -4 plus 9. Keep the base n, -4 plus 9. Use a calculator if you have to, but you should be able to do 9 minus 4 is 5. For here, now I'm not using a variable, I'm using a number. I have 7, and I'm adding 13 plus 19. Boy, I'm glad I don't have to write that one out in expanded notation. That would be quite a lot of expanding, huh? 7 to the 32nd power. Again, you can use a calculator. Base here is a. I'm adding the exponents, 7 plus 10. but I have a different base. I have base b, and I'm adding those exponents separately, 4 plus -3. You can only combine the exponents when the bases are the same. I have two bases in the same expression, so I gotta be a little careful with that. And I'm gonna end up with a to the 17th power, b to the first power. Ugh, ugly math. You know how I feel about writing those ones in. So I'm just gonna rewrite that problem. And I'm not gonna put the 1 there. A to the 17th and just b. And I'm gonna put a little aside down here, a little bit of a star. Because if there's no exponent, the exponent is 1. So if there's no exponent given, use a 1. Conversely, or opposite of that, but if the exponent is 1, you don't write it. If the exponent is 1, in your answer, don't write it. Okay. Another time to pause the video and try the problems on the next page. There's only 2 of them, so pause the video, take a breath, and do problems on page 18. All right, I hope you tried them. I have faith in you. Both of these are false. This one is 5 to the 3rd power times 5 to the 2nd power, and they're saying that it's equal to 25 to the 5th power. That is not equal. I'm gonna make that a not equal sign because this is false. One of the most important things about the product rule of exponents is you keep the base. So the error is they did not keep the base. And the correction is, you must keep the base. So I'm going to rewrite this problem and correct it. 5 to the 3rd power times 5 squared. Well, you keep the base, 5, and now you're adding the exponents, 3 plus 2, and you get 5 to the 5th power. Well, let's take a look at this one. X to the 3rd power times x squared is, that's not x to the, that is very wrong, false. So what did they do there? They did not add the bases. Sorry, I just said add the bases, that's wrong. They did not add the exponents. And you know you have to add the exponents. So I'm going to rewrite that one. X to the 3rd power times x squared is going to be equal to x to the 3 plus 2 or x to the 5th power. All right, that's enough for today, I think. Take care.